Okay, so what we're going to do is we're going to look at one of the other ways that would determine the enthalpy change for a reaction. Now, we've already looked at calorimetry, and so now all we have to do, what we're going to do is we're going to look at Hess's law. Now, Hess's law basically states, if I have a series of reactions and I add them up, and come up with any third reaction, or 4, then the enthalpy change for the reaction that resulted from the addition, it would be equal to the sum of the enthalpy changes of each of the reactions. So to make sense of this, let's look at a specific example. So for example, here we have the reaction, and we want to know the enthalpy change for the combustion of methane to produce carbon dioxide and water in the gaseous form. And we're given 2 reactions. Our first reaction states the enthalpy change for the combustion of methane, and it produces water liquid. And then our second reaction shows the conversion of liquid water into water vapor. So the first step when we want to solve these is to write out our equations as given. Now sometimes we're given all the reactions, sometimes we're not, but we're given information to get the reactions. And we'll look at this type of example at a later date. Then the next step is to identify required entities in each of the reactions for my target equation. And so in my first reaction, I have methane, oxygen, and carbon dioxide that are all in my target equation. So therefore, I've circled all of them. Now I suggest that we circle them so that we can keep straight what we're going to do. There's water in my first reaction, but it's not in the right state, so that's why I didn't circle it. In my second reaction, I have water in the correct state, so therefore I circled that. So now I know which reactions I have to use, and so now our next step is to identify how each of them would be used. And so what I can do is I can look at, in my first reaction, I have 1 methane, and I have 1 methane in my target equation. And the methane in the first reaction is in reactants, and in my target equation is also in reactants. So that suggests that my first reaction I'll use as is. But my second reaction, I need 2 water in the gaseous form, but the reaction only has 1. So therefore, I need to take this reaction and multiply it by a factor so that I have the correct number of waters. So if I multiply all the coefficients and the enthalpy change by 2, then what I can do is I can get the correct number of water gaseous in the second equation. So now I have all of the entities identified, and so my next thing will be to add them up to show that they add to the target. Now, if we do this properly and we line up our arrows, then what this allows me to do is to cancel things out and treat the arrows as an equal sign before I can combine them. And so I have 2 liquid waters in the product side of the first reaction, and I have 2 liquid waters in the reactant side of the second reaction. And so since they're the same molecule in the same state, I can cancel them out. So now I add my 2 reactions together, and I see that it adds up to the target equation. So this tells me that my enthalpy change for my target equation will be equal to the enthalpy change of the first reaction plus 2 times the enthalpy change of the second reaction. So now I can substitute in my values and solve, and I know what my enthalpy change is. So let's take a look at a second example. So here I have 3 reactions, and I want to know for the addition reaction of a hydrogen to my ethene to make ethane, what would be the enthalpy change? And so we're given a series of enthalpy changes, and they're mainly all for combustion reactions. And so I have the information for combustion reaction of ethene. I have the enthalpy change for the combustion reaction of ethane, and I also have the enthalpy change for decomposition of water. So again, just like we did before, first step, we write out all of the reactions that we have. And then my second step, identify things that are required. And so I identified my ethene in the first reaction, my ethane in the second reaction, because they're both in the target equation, and I identified the hydrogen in my third reaction. So now what I'm going to do is I have to look to see are the reactions written in the right way, and do I have the right coefficients, and is the compound on the correct side for my target equation. So from the first reaction, my ethene, C2H4, it's in the reaction side, and the target equation is in the reactant side. So therefore, I can use the reaction as is. In my second reaction, my ethane, C2H6, is in reactants, but in the target equation is in products. So that means I need to flip this reaction. And so to flip, I multiply it by a -1. Similarly, in the third reaction, my hydrogen is in the products. My target equation is in reactants. So I need to also flip this third reaction. So I'll also multiply that by -1. Okay. And so because I'm changing the reactions, I'll rewrite them. And so now here I have them rewritten with all of the required elements on the correct side. So now our next step is to show that they add up to the target. So I can see that the carbon dioxides will cancel. The waters will also all cancel, as will all the oxygens. And I'm left with only the three things in my target equation. So this tells me that I probably did it right. I'll just add it up, see that they get to the target. So therefore, this tells me that I'm using each of my reactions in the right way. So therefore, the enthalpy change for my target equation will be the enthalpy change of the first reaction plus -1 times the enthalpy change for the second reaction plus -1 for the enthalpy change of the third reaction. So now I can just substitute my values and get my enthalpy change.